Hello everyone, welcome to GATEFORUM. So let's start this video. In this video, we will be discussing beams with internal hinge, and we will be solving some good questions from the previous gate also. So basically what happened from this very important topic, that is shear force and bending moment diagram. Basically this type of question is very common or most expected question every time in the gate examination, from shear force and bending moment diagram. So what do we mean by, first of all, internal hinge? And if we have beams with internal hinge, then how we can able to solve the problem? That means if beams with internal hinge, then how we can able to find out the value of shear force as well as bending moment, we will see in this video, or we will learn in this video. So let's, okay. So first of all, what do we mean by internal hinge? Just look at here. Suppose if here we have beam which is connected with a hinge here like this. Here we have a beam which is connected with a hinge like this. Here we have. So this one is known as internal hinge. Hinge between two beams. This one is known as internal hinge first of all. This one is known as internal hinge, or this can be represented like this. Suppose here we have two beams and one internal hinge here like this, This is, or this can be represented this way: one beam, internal hinge, then one beam like this only. So any one representation, either this representation or this or this. In examination, any type of representation can be given to you to show the internal hinge. To show the internal hinge. This will be also internal hinge. This will be also internal hinge. So any type of representation will be showing the internal hinge. So please remember these diagram, so that you can come to know that here we have one internal hinge inside the beam here first of all. So first of all, we have come to know that what is internal hinge. Now, if suppose we have a beam and we need to find out the value of shear force or bending moment diagram, shear force or bending moment, either for the first beam or for the second beam, because here this one is the first beam, here this one is the first beam. Just look at here, this one is beam number 1, this is beam number 1, and this one is beam number 2. Here we have beam number 2. So in exam may be possible that he will ask you to find out the value of shear force or bending moment for beam 1 or for beam 2. Okay, just take one example. Suppose here we have a beam. Just take one example. Suppose here we have a beam like this. Suppose here we have a beam having internal hinge in between somewhere here. Internal hinge like this. And here we have a simply supported beam like this. Here we have, suppose, hinge and roller. Here we have, suppose here we have hinge, roller, as well as here we have a roller or hinge like this only. Suppose this point is A, this point is B, hinge point is C, and this point is D like this only. Okay, and load is acting here. Suppose any type of, suppose if you're going for some load, some value of load here, some value of load is acting here W, some value of load is acting here W. Okay, some value of load is acting here W, and some UDL will be acting here on the first beam. Some UDL will be acting here for the first beam, that is W Newton per meter. W Newton, and here it is W Newton per meter. And suppose it is asked to find out the value of bending moment at point B. Bending moment at point B. Let's say here we have bending moment at point B. If this type of question will be here, then how we can calculate the value of bending moment at point B? Just look at here. So for bending moment at point B, what I can say, how we can go for the bending moment point. How many support here basically we have? At point A we have a support. Just look at here, one hinge here at point A. Okay, one hinge here at point A. At point B here we have one roller support, and at D here also we have a roller support here, and here we have at C one internal hinge. So for point B, bending moment, we need to get the values. Here. So many unknowns here we have. So how to find out the unknown? First of all, how to find the support reaction? So what is the first step in this type of problem we have to take? We will decide. Okay, only we will proceed with this method only. Okay, in this way only. As in my last video, I have taught you that if we have beams with the bracket, then how we can solve the problem. What was the first step there? Just remove the bracket and put the equivalent load as well as moment. Here, in the same way, here, what is the first step? So I'm writing here the first step. So the first step here we have. So the first step. So the first step here we have. First step here we have. What is the first step? First step, separate the beam from the point of hinge. Separate the beam. First step is separate the beam. First of all, separate the beam. Separate the beam from point of internal hinge. From point of internal hinge. From point of internal hinge. Internal hinge. And then solve beam 1 and 2 separately. Then solve beam 1 and beam 2 separately. Beam 1 and beam 2 separately. Whatever asked you can find out. Whatever asked you can find out. Just look at here. Here in this case, suppose if I want to separate these two. If I want to separate these two, so I am writing here. This is the first part of the beam. This is the first part of the beam. So here we have one hinge. Here we have one roller at point A, at point B, okay, at point C here. Okay. Now second portion of beam is here. Now second portion of beam is here. That is point C as well as D. Point C as well as point D. And here we have one roller support. Now what about hinge at C? Here we have hinge at C here. So we have separated this beam from the point of hinge only. We have separated the beam from the point of hinge only. So what happened? At time of hinge, we have basically support reaction. We have basically support reaction in both horizontal as well as vertical direction. But ignoring the horizontal one, I can put here one support reaction, let's say R. Let's say R here we have. Let's say R here, or you can write RC here. You can write RC here. Same equal and opposite RC will be applied here. Same equal and opposite RC will be, because once we again join the beam, once we again connect the beam at point C with internal hinge, both RC will get cancelled. Both RC will get cancelled. Now separate beam will be done. Now separate beam will be done and loading will be also there. Here we have loading of UDL like this, and here we have loading of W at center. Here we have loading W. So here we have beam 1 separately. Here we have beam 1 we have separated. And here we have beam 2 we have separated first of all. So first of all we have done the separation. First of all we have done the separation for beam 1 as well as beam 2. You can see here. This is the only first step. Please follow the first step. Please start the solution in this way only. Whenever we have internal hinge in the beam and we need to calculate the value of shear force or bending moment. So please start from here only. And now which portion has to be solved first? Beam 1 has to be solved first and beam 2 has to be solved first. So I am writing solve beam 2 first, then beam 1. Why I am writing here solve beam 2 first, solve beam 2 first, and then solve beam 1, and then solve beam 1, then solve beam number 1. Why I have said like this, that solve beam 2? Because number of unknowns in the beam 2 is less. How many number of unknowns here? I'm writing the number of unknowns also. I'm writing the number of unknowns here. In the beam number 1, how many unknown here? RC as well as 1 here, RD will be here. Here we have RD will be here. So in beam number 1, 2 unknowns here we have. 2 unknown support reactions here we have. So very easily we can able to find out the value of support reaction. So what will be here? So W by 2 we here. So this value will be, RC will be equal to W by 2 and RD will be also equal to W by 2. Only 2 unknowns here. That's why. But here how many unknown? Here RA will be unknown here. Here RA will be unknown. Then here RB will be also unknown. Here RB will be also unknown. And RC will be also 3 unknowns here we have. Here we have 3 unknowns. Here we have 3 unknowns in beam number 1. That's why, because beam 2 having only 2 unknowns, so go for the beam 2 first. So solve the beam 2 first, so that we can get the value of RC at least. So that we can get the value of RC at least, which is equal to W by 2. Now here RC which will be also equal to W by 2. Here RC will be equal to W by 2. Now once I get the value of RC equals to W by 2, or any value of RC, once I get any value of RC, now same RC value will be here on the first beam, but opposite in the direction, which is the downward direction. And now in the beam 1 also we have only 2 unknown right now, and now we can able to solve. We can get the value of 2 unknown on the support reactions, and we can easily calculate the value of shear force as well as bending moment. Shear force as well as bending moment, very simply. Very simply. Now how to find out the value of bending moment at point B? Just look at here. So first we have done beam 2, so that we can get the value of RC as W by 2. RC as W by 2, and now I will calculate the value of bending moment for point B. And now I will calculate the value of bending moment for point B. Just look at here. Here we have beam. Here we have beam like this. Here we have beam like this. Point A, B, C. Here we have right. Here we have point B, and here we have point C, and here we have point C. So RC which is equal to W by 2. RC which is equal to W by 2, and here we have point load. Here we have UDL. UDL we have like this only. W Newton per meter, W. So no need to calculate RA even. No need to calculate RB. No need to calculate. I am writing no need to calculate. No need to calculate. No need to calculate RA and RB. RA and RB. No need to calculate RA and RB. Why no need to calculate RA and RB? Because we don't need the value. Because we need to find out the value bending moment at point B. Because we need to find out the value of bending moment at point B here at point B only. Na? So very simply what I can say, so value of moment at point B will be equal to, from the right hand side, what we can say, RC multiplied by L, suppose this length, this value, length is given as, suppose from here to here, this length is given as, let's say L, and this length is also given as, let's say L, this length is also given as. So here RC multiplied by, that is W by 2, multiplied by L, which is negative in sign, here we have, okay, then minus, here we have W, so W into L is square by 2, W into L is square, because from here to here, this value will be W from here to here, so W into L is the value of point load into L by 2, WL square by 2. So this will be the value of bending moment at point C, and this will be our answer. This will be our answer here. So what is the first step first of all? So the first step is to separate the beam from the point of the internal hinge and then solve beam 1 as well as beam 2. But which beam has to be solved first? Which beam has to be solved first, where number of unknowns will be lesser? Here we have done beam 2 first because we need to get the value of RC. Once we get the value of RC on the beam 2, the same value of RC will be on the beam 1, but opposite in direction, which is in the downward direction. Okay, now once you got the value of RC, that is the support reaction at the internal hinge, then you can solve any part of the beam. You can find out any shear force or any bending moment. Very simply you can do. Let me move to the problem. From the previous gate. Here we have one problem from the previous gate, as you can see, from gate 2015 IIT Kanpur. Here we have one problem from PY. Just look at here. Here we have a cantilever beam OP is connected to another beam PQ with a pin joint as shown in figure. So here we have a pin joint, that is internal hinge at point P here. Load of 10 kN is applied at the midpoint of PQ. Here it is applied here. The magnitude of bending moment in Newton per meter at the fixed end O. Very simple. Here at O, we need to find out the value of M at O. That is the in beam 1. In beam 1, we need to get the value of moment at point O only. Okay, if we separate these two, what is the first step? First step is to separate the two beams from the point of internal hinge. Suppose we have separated. So because of here we have one support reaction and here we have internal hinge support reaction. So here we have RP and here we have RQ first of all. And load is acting here. How much load is acting here? 10 kilonewton. 10 kilonewton load is acting here. Okay. Now here at this point P, equal and opposite RP will be here. Equal and opposite RP will be here also. So we need to get the value of RP, because here if this point is O now, if this point is O here, if somebody will ask you what is the bending moment at O, you will say simply means O means only one load here, RP multiplied by the length 2 meter. Length, because this is a length 2 meter. RP into 2 meter only, this 2 meter only, RP into 2. But what is RP? We are not knowing RP. We are not knowing RP now. So solve the beam 2 first. Solve the beam 2 first. Solving this part first. So since here we have center, so symmetry, half of load will be here. Half of load will be here. So 5 kilonewton here and 5 kilonewton here. 5 kilonewton here and 5 kilonewton here we have load. So simply this value also 5 kilonewton, because equal and opposite. So we have solved beam 2 first. We have solved the beam 2 first. Beam 2 done first. Beam 2 done first. Why beam 2 done first? So that we can able to get the value of RP as 5 kilonewton, and then here we have RP 5 newton. So what is the value of moment at point O? So the value of moment RP means it is 5 only na. 5 multiplied by 2. And here it is only 10 kilonewton meter, and you are not, your sensor, you are not getting minus sign here. Sir, why you are leaving this minus sign? Why you are leaving this minus sign here, negative sign here? Why you are leaving this negative sign? Because here it is as the magnitude only, magnitude of the bending moment at point O. So we will not go going for the sign plus or minus. That's why I was leaving. But actually it is minus 5 into 2, that is minus 10 kilonewton meter. Actually it is minus 10, but right answer is 10, because magnitude here we have. So leaving the sign here also negative sign here na. So leaving the sign here. So I'm leaving sign. That's why right answer is 10. Very simple. As you can see, this question was in GATE 2015 2 marks problem. 2 marks problem here in GATE 2015, 2 marks problem from IIT Kanpur. Very good problem from the internal hinge. If a student is knowing the concept well in this way, the way I have taught you, simply within 30-40 seconds, student can able to solve the problem. Very simple, very simple. Let's move to the next problem. Let's move to the next problem. Here we have next problem from GATE 2005 IIT Bombay. From GATE 2005 IIT Bombay with beams with internal hinge. Beams with 2 marks problem. Here it is 2 marks problem on again. 2 marks problem again here. Very simple. Very simple. How to do? Just separate. What to find out? The bending moment at A here. Same problem. The bending moment here at A. At this point A, what is the value of moment here? What is the value of moment here at that point? Very simple. Just separate the two portion. Just separate the two beam na. Just separate the two beam here. First beam here we have, and second beam here we have, and second beam here we have. So here we have RB. Here we have internal hinge RB here reaction, and here we have RC. Here we have RC, and load is acting as P. Load is acting as P, and where load is acting at L by 2 na. L by 2 here, L by 2 here. So half of load will be half of support reaction. So this will be P by 2, and this will be also P by 2. This will be also P by 2, P by 2, P by 2. So here also P by 2 will be here. Here also P by 2 here. So what about at point A? So moment about A will be nothing but only P by 2. This P by 2 multiplied by the length L. This length L only. Actually minus sign here, minus sign also here. But we need to get the value of the bending moment here. But in the options there is no minus sign here. No minus sign, that means magnitude only. That means only magnitude we need to get the value magnitude only. So moment at A will be equal to minus PL by 2. Minus PL by 2, this will be our answer, but we should go for magnitude only. So leave the sign PL by 2. So option B will be correct here. Option B, PL by 2 will be correct. As you can see, this question was also very simple from GATE 2005. GATE 2005, and within 30 seconds we can able to solve. And this question from GATE 2015 also very simple from IIT Kanpur from 2015. Very simple, within 30 seconds we can able to solve. So as you can see, questions are very easy. As you can see, questions are very easy. You just need to know the concepts well. Once you know the concepts well, very easily within 30 seconds, 40 seconds you can able to solve any question from the strength of material subject, whether you are from mechanical engineering or whether you are for civil engineering. If you are a mechanical student or if you are from the civil, no matter just go for the concepts in the best way. Okay, we need to just work out on the concepts very straight way, right concepts, so that it will save your time in the gate examination. So you're watching this video on the Gate Forum YouTube channel, and I'm putting all these videos in a particular series for the strength of metal. You can watch all this, and if you find this video very helpful, definitely this video will be very helpful for you, right? Because okay, because I'm getting I'm teaching the concepts in the best possible way from the strength of material. So please like the video, subscribe this YouTube channel, hit the bell icon, and please share this video with your friends also. Okay, so watch all the videos of this series of strength of material on this YouTube channel, and I will meet you in the next video with next topic. Okay, bye, all of you, bye.